April the 30th, 2020. My name is Yoz Graham, and I am a developer advocate for LaunchDarkly. Joining me today is Casey Rosenthal, the CEO and founder of Verica.io. Hi, Casey. Thank you for joining us.
That's my pleasure. Happy to be
Uh,
here.
Thank you. And sorry we started a bit late today because I suddenly remembered that I had to get my waistcoat on. Somehow I was without my waistcoat. And, in times like these, I think we agree it's all important to keep up the semblance or mirage of appearances. So Casey, you are the man who literally wrote the book on chaos engineering, or co-wrote the book, which is recently out from O'Reilly.
Yep, wrote it. Co-wrote it with Nora Jones, and we had a bunch of contributing authors, which was great. We got perspectives from companies like Google, Slack, Microsoft, LinkedIn, Capital One, stuff like that.
Cool. It's I had a brief skim through it before, and there's some fascinating stuff which I believe you're about to go over now. So let's take it through to the slides, and there will be questions and answers from the audience afterwards. So if you're listening, please join in the chat and pose any questions. Casey will be talking for about 20 minutes or so, and then we will open it up. So take it away, Casey.
Great. And yes, let's make sure there are at least questions and hopefully answers. Just to verify, you can see my title slide here? Okay, perfect. So I'm going to talk about a couple different mental models and how those relate back to doing things in production and some of the evolution that we're seeing in, for lack of a better word, DevOps and best practices across the industry. I work at a company called Verica. I'm not going to talk about that though. I'm going to try something a little bit different. I'm going to start by presenting a couple of myths about reliable systems, about what makes systems reliable. And this is partly to stir up controversy, but also I just want to see how people react to me starting off with these instead of leading people into them. So one of the myths of reliable systems is that you can make a system more reliable if you remove the people who cause accidents. So this assumes that there are people who are accident prone or less careful. It's sometimes referred to as the bad apples management principle. And the data just overwhelmingly shows that this is not the case. Unfortunately, the medical system in the US has occasionally tried things like this. For example, something like 80% of the malpractice lawsuits are associated with like 5% of the doctors in the US, which on the face of it sounds like, oh, well, clearly those are bad doctors. Get rid of them, and the malpractice cases will go down. Unfortunately, it's just the opposite. Doctors who are particularly good at handling high-risk cases tend to congregate in that area, and so that's why they're associated with the higher numbers of malpractice suits. So if you get rid of them, you're getting rid of the people who actually have the most expertise to handle those kinds of situations. So the same applies for your system. If you have a team or a person who seems to be coincidentally associated with reliability issues, getting rid of that person is not likely to make the system more reliable. Second myth is document best practices and run books. That will make a system more reliable. Not true. I'm not saying that you shouldn't document things, particularly if that's an effective way to communicate within your organization. However, most critical outages are unique. So there are no best practices for that. I mean, let's be honest, there are no best practices in the industry. There are just common industry practices. We have no idea what would constitute a best practice in a complex system. And run books, again, while they can be an effective way for somebody to codify their own personal knowledge or communicate that, in order to really have a reliable system, in order to move the needle on reliability, you need people with experience. Run books don't suffice. Humans can't download experience to each other in that way, particularly not the kind of experience that is required for improvisation and adaptation. Third myth, if you identify prior root causes and defend against them, you'll make your system more reliable. This is particularly appealing. Again, all these myths are intuitive, right? That's why they're easy to believe. But there's a couple of things wrong with this. One is if you just identify vulnerabilities and defend against those in a complex system, again, you're not necessarily preventing the things that generate new, unique vulnerabilities. The other is that root cause doesn't exist in a complex system. And in the interest of being mildly controversial, I'll go a step further and say, if you are doing root cause analysis, at best, you are wasting your time, because root cause doesn't exist in complex systems, and that the practice of root cause analysis is a bureaucratic exercise to assign blame in a particular narrative that doesn't actually benefit the system or make it more reliable. I would love to dive more into that in the Q&A part of this meetup. The fourth is that you can enforce procedures. This assumes that somebody knows better and that the people doing the work actually just aren't following the rules. That's almost never the case in a system that needs improvement for reliability, particularly in a complex system. Usually that's more indicative of a mismatch between how work is imagined by people higher up in the hierarchy and how work is actually done on the front lines. Myth 5 is that if you avoid risk, you'll make the system safer. This seems very intuitive. Don't do the risky things. We hear this in the enterprise a lot now, the phrase guardrails. If you just put guardrails in and avoid risk, then you make a system safer. So guardrails do two things that are counterproductive to making a system more reliable. The first is that they prevent people from gaining the experience necessary to adapt and improvise and innovate to make a system more reliable or to remediate an incident as it's happening. And the other thing that guardrails do is they tend to become obstacles for the people best positioned to remediate an incident while it's happening. So again, as intuitive as this sounds, it turns out to be counterproductive in practice. Sixth myth is you simplify your system, it'll become more highly available or safer. Complex systems, right, the problem is the complexity. So just take the complexity out of it and you'll have a better system. Again, a couple of things wrong with this. One is that empirically, we know that more complex systems are safer or more available than simpler systems. So the data just backs that up. But complexity also tracks with business success. So your customers are paying you for complexity. Like that's, as you know, one way to view your job as a software engineer is you're adding complexity to a product. So if you remove complexity, you're actually removing the ceiling for how successful your product can be. Another way to look at this is accidental complexity is going to always grow as a process of doing work in software. And essential complexity, that's complexity you put in there on purpose, as feature development, stuff like that, that is also going to grow. So if both forms of complexity are always going to grow, we don't have a way as an industry of sustainably reducing complexity. So that is not going to make your system more reliable. And the last myth that I'll mention here is that redundancy equals better reliability. And this is really interesting. There's a lot more research to be done here because the relationship between redundancy and availability in particular isn't as well understood as we would like. But we can certainly point to many examples where redundancy was a contributing factor to a failure, to an incident. This is true in software, but famously it's true in hardware, aviation, rockets, the Challenger incident, where redundancy is, again, actually a contributing factor to an outage or an incident or some sort of system failure. So at best, redundancy is orthogonal to reliability. So I'm going to start by presenting those, and hopefully there's something there for everybody to disagree with. But now I'll present a couple mental models, frameworks to think about things, and we'll tie it in with with feature flags, but also with continuous verification and some other stuff. So here's one model that makes some provides one framework to think about how engineers make the design decisions that they make every day that we don't necessarily talk about. So in this model, engineers are basically in the middle between these three poles. The poles are economics, workload, and safety. And you can imagine the engineers attached by a rubber band to each of these three poles. And if they stray too far from one of these poles, the rubber band snaps and it's game over. So implicitly, engineers know that they have an intuition of how far they are from the economics pole, right? You probably do not have a rule at your company that new engineers are not allowed to spin up 1 million instances of AWS EC2, right? Why don't you have that kind of rule? Well, it's kind of common sense. Engineers implicitly understand that things cost money, they cost money, their team costs money, and they know they're not supposed to spend more money than they have. So they try to balance that out as they make decisions throughout their day. The same is true of workload. Engineers implicitly understand that their servers can handle some amount of work. They, as people, can only type so fast, can only write as a certain number of features per day, or have a certain amount of feature velocity. So they intuitively understand the relationship to that pole, and they make sure that they don't drift too far from it, or they know their servers will be overloaded, the resources will be overloaded, or they'll burn out. Right. The same is true with safety. The difference is they have no intuition as to how close they are to that safety pole. And I'm comfortable making that generalization across the industry because we still have incidents. The reason we have outages and security breaches and things like that is because they're surprises. If we knew one was about to come as an engineer, we would stop what we're doing and we would change what we're doing to make sure that that doesn't happen. We would implicitly change our behavior. This is one of the models, one of the frameworks that provides a foundation for understanding chaos engineering. And we have the definition here at principlesofchaos.org. This is my favorite definition, the facilitation of experiments to uncover systemic weaknesses. So what chaos engineering does is it teaches us about that safety margin. It teaches us, it helps us generate an intuition of how far we are from that safety pole. And just knowing that implicitly changes the decisions we make as engineers, which is quite powerful. The other thing chaos engineering does, here are some of the advanced principles. You can see right there in the middle, one of the advanced principles is run experiments in production. And we can talk about this. I hope there are questions about this. But this isn't to say that running experiments, chaos engineering experiments, to uncover systemic weaknesses isn't also valuable in staging or non-production environments. It is. We can provide plenty of examples of where learning there has been really useful. But ultimately, in a complex system, you want to study the actual system you care about. And so the gold standard, the highest bar for chaos engineering, is running those experiments in the actual production system. So that's one model. I'll introduce another one here called the economic pillars of complexity. And again, this is just to frame how we think about the evolution of technology. So in this model, there are 4 pillars: states, relationships, the environment, and reversibility. And the quintessential example of this model is Ford in the 19-teens, where they were able to control the number of states in their manufacturing process by saying, you can have whatever kind of car you want as long as it's a black Model T. And so their ability to control one of these pillars helped them navigate the complexity of their manufacturing and production service. They were able to also control relationships. Other car companies had teams of people who built a car from the ground up. Ford moved to assembly line manufacturing and scientific management and Taylorism to basically limit the relationships between the parts, but also between the peoples. That helped them navigate the complexity of their marketplace. They also controlled their environment or affected their environment by first breaking up the automotive trust in the U.S., which allowed them room to do business, and ultimately they became somewhat of a monopoly themselves. So they were able to control their environment that way. Which brings us to the fourth one, reversibility. And here's where Ford couldn't really do anything because while you can put a car in reverse, you can't really reverse the manufacturing process. Reversibility was not something that Ford could optimize for. So how does this model apply to software? Well, states, and we don't just mean data, but the functionality of applications are usually increasing. Usually you're paid to add features as a software engineer. So there's not much you can really do to control that pillar. Relationships. Unfortunately, we're in the business of adding layers of abstraction. So whether we want to or not, the relationships between the moving parts, and now more of us are working remotely, that adds a different dimension of complication to human relationships, and explicit architectural changes to things like microservices so that we can uncouple the delivery cycle of features. There's not much we can do in software to control the relationships. That's expanding. The environment, most of us are not monopolies, so we can't affect our environment too much. Amazon. Which brings us to the last one, reversibility. Here's where software shines. And we can see, obviously, it's software, not hardware, but we can see this in great effect in first the move from waterfall to XP and Agile, where waterfall said, we'll plan the whole thing, we'll build it, we'll deliver it to the customer after a year. The customer will say, no, that's not what I wanted. We'll say tough, and then keep moving forward. And so XP said, if we can, we'll just put something in front of the customer after, a week or whatever. And the customer says, no, that's not what I wanted. Okay, it's easy to reverse that decision. We can throw away a week easy enough. And then, the second week, we put something else in front and say, yeah, kind of. And hopefully by the third week, we're tracking with what the customer actually wants or needs. That was a sophisticated implementation of reversibility as a way to navigate a new complex manufacturing or production process. But we can explicitly make architectural decisions that prove reversibility as well. And there are a few better examples of this than feature flags. So feature flags help us navigate a complex system of manufacturing, producing software by explicitly enabling us with this architectural reversibility decision. And that's important. Other things that add that source control, automated canaries, blue-green deployments, chaos engineering as part of the feedback loop, observability as part of the feedback loop. These things all improve reversibility, and that pays dividends for navigating complex systems. The last thing I'll mention here with respect to software and mental models is, sorry for the block of text here, but the chief merit of software engineering is its technical efficiency with a premium placed on precision, speed, expert control, continuity, discretion, and optimal returns on input. It's a mouthful, but a pretty good definition of software engineering, except I accidentally did this. The actual quote is, that's the chief merit of bureaucracy. And I just want to make that point. Software engineering is, in some circles, known as the bureaucratic profession. And that sounds like a negative thing, and it probably is. So why would somebody make that claim? Well, no other industry has done a better job of separating who decides what needs to be done from who decides how it needs to be done from the people doing the actual work. That is an idealized bureaucracy. So chief architects, product managers, project managers, people managers, tech leads, all of those roles exist to take responsibility, decision-making responsibility away from the people doing the actual work. And this all goes back to scientific management and Taylorism from the 19-teens. And we can discuss historically why that's the case, but we should understand that this is the wrong software. This is the wrong model for software engineering if you consider software engineering to be knowledge work. It's the right model, it's a model that's acceptable for manufacturing widgets, most of us are not manufacturing widgets. So if you consider software engineering to be knowledge work, then that hierarchy, that bureaucracy, is a counterproductive model. So all of this is to say we're not trying to fight complexity, we're trying to navigate it. Very quickly, this is part of an evolution that we're seeing from CI, continuous integration, which limited the number of bugs that we can create by merging code faster so that the bugs become more apparent and don't geometrically lead to larger numbers of bugs. And then we saw that, the engineers can create features faster. That evolved into continuous delivery, CD. Okay, now that we can make software faster, we need to get it to production faster and roll forward faster, change our mind. So there's an important part of reversibility that's enabled by this evolution. And now we're seeing the industry start to develop CV, continuous verification, which says, okay, if under the hood we have all of this complex software creation moving very quickly, how do we keep our eyes on the road? How do we make sure that we get the behaviors out of a complex system that the business requires, given that we're enabling very fast movement of feature velocity and getting that to production? Basically, how do we move fast and not break things? And here's another way of envisioning that. Continuous verification, I'm just reading across the top here, is a proactive experimentation tool that verifies system behaviors, whereas most of what the industry is currently familiar with falls more along the line on the bottom there. It's reactive testing methodologies that validate known properties. And those things along the bottom are good. They're useful. We're not saying don't do those. Certainly not advocating that you should ditch testing. But those practices and disciplines were born in a time of simpler systems, and they're more attuned to simpler systems. In complex systems, you have to move up these scales to ensure the business properties that you want out of your complex systems. So tools don't create reliability, humans do, but tools can really help. We've got this book out, and there's a way you can get a free book if you go to this link. I would love to take questions now.
So can you hear me all right, Casey? Is that I'm
Yes,
going to leave that slide on the screen for a while, because just so I can copy the URL, and it's Kim, our producer, and I, in the background, while you've been talking, have been absolutely squeeing with joy, because this has hit a whole bunch of buttons. This talk has hit a load of stuff that we have been talking about for a while. I tweeted your quote about software engineering, separating those who decide what needs to be done from those who decide how to do it. It's this. Thank you so much for this. And there's so much to go into here. I mean, if you are watching, please give us your questions, your reactions, especially because there's actually, you know what, we will put the URL. Kim, if you could put the URL there in the comments so that other people can get to it while I switch the view here.
Be great.
There's a lot, as you warned us at the start, that there were things that you would be going into that run quite counter to current practice. And thank you, Kim. And hang on a second, let me get my camera back. So there we go. Unfortunately, well, I should preface by saying we have been testing in production here with this stream and doing the chaos thing in the truest way, which is to be, looking calm on the surface while paddling like hell underneath. For 3 minutes during your talk, I completely lost connectivity. So I'm afraid there may be some things I ask about that you already discussed, and please tell me if that happens, because I don't want to bore anybody. But there's so much to go into here. I think, given the way that some of the things that you talked about in your myths, that I feel somewhat attacked. I always thought, documenting best practices and run books are vital. And there's the point you made. I mean, if we could just go into that a bit more about the value of personal experience and how you see that playing out in the organizations you've worked with.
Yeah, sure. So, let's first talk about the definition of resilience. So, outside of software, there's this field of resilience engineering, and the most effective, I think, definition of resilience is having an adaptive capacity to handle incidents.
Right.
So that adaptive capacity, it requires a level of improvisation, right? It requires humans who have skills and context to know how to improvise.
Right.
A run book simply doesn't have that. It simply can't have that. So even if you have something very well documented, what you can't do in that run book is provide enough context or skill or experience around that to let the person following the run book know that if it's even the right run book that they should be following, right? If they have to consult a run book, then it's basically a guess on their part. And if it's a guess on their part, then you've basically capped the reliability at which your system can operate. So you can't move the needle on reliability by investing more in run books. Is the takeaway there. Now, documentation, hey, if that's a way that you like to communicate, that's great. You should obviously get better. Communication is the hardest thing in most professions. So, you should obviously take advantage of the ways that you can do that well and invest and do that better. But that's not going to improve reliability.
Right. And it's fascinating because, one of the trendiest books in the past 20 years around this is Atul Gawande's Checklist Manifesto. And I can't remember if that was the actual title of the book. But something that came from the medical profession is this idea of rigorously adhering to checklists in crisis situations. Is that the same thing as run books, or is there a difference that I'm missing there?
I think there's a difference. So using a tool that you have experience with to help you get a job done, fine, great, absolutely. But that's different from a run book that's trying to suffice. It's trying to supplant or be sufficient to take the place of a human improvisation or adaptation.
Mm.
Does that make sense? So
yes,
a run book is a remediation tactic. A checklist should not be used as a remediation tactic. That's a tool to help you, basically bring your experience forward.
So, or maybe it's about diagnosis so that you can fully establish what assumptions you're making, or give you the full set of facts before you start trying to remediate.
A lot of times it's not, checklists don't have nothing to do with remediation, right? Like, so a pilot going through a checklist before they take off, making sure that you don't forget something. Sure, you're relying on a tool of the trade to help you bring your own experience forward. But again, much different from a run book where
it's about remediation. Right. Yeah. So, and that's also fascinating, given that it plays into some of the old, sayings and terrible jokes that we got from the 60s to the 80s about automation. In that, the thing about the nuclear reactor has a dog and a man, and the man is there to be at the controls, and the dog is there to bite the man in case he tries to touch any of the controls. It's the idea that the automated systems are the reliable part and the humans are the unreliable organic part, but it's the organic nature and the ability to improvise that actually brings us the reliability here.
It brings the resilience. Yeah, you can have a robust system with a lot of automation, but it's but by definition you can't make a system more resilient with automation. because so far, at least, we don't have the capability to automate improvisation.
Right, and so have you seen? I mean, I've seen recently more work towards supposedly self-healing systems. Um,
Mhm.
I know that some companies, especially those in the performance or alerting and monitoring space, are doing this self-healing thing, especially those trying to use AI, I suppose, to spot outliers or try and make connections between cause and effect, and things like that. Have you seen any success there? Anything there that you think is worthwhile?
Sure. Again, you can raise the floor of robustness by implementing and really self-healing is like calling something AI, right? It's like what we call
Mm-hmm.
self-healing will tomorrow just be like an algorithm. So if you look at things like the bulwark pattern, circuit breakers, or um,
Mm-hmm.
uh, failure conditions, those were self-healing 10 or 20 years ago. So
Right.
having a system that detects something out of range or even alerting is a primitive form of self-healing, right?
Right.
It just doesn't go all the way. It just brings a human in instead of something else. So that's a perfectly valid algorithm for making a system more robust. But again, you're lacking that improvisation and context picture. So
Right.
putting the newer buzzwordy sound around it of self-healing doesn't make your
Mm-hmm.
system more resilient because it's not bringing in more intelligence than an engineer can think of ahead of time. And what we know in complex systems is that what the defining quality of a complex system versus a simple one is that a complex system can't fit in one person's head.
Right.
So it's not reasonable to assume that a software engineer can think of all of the things ahead of time that can go wrong with the system.
Right.
And if that's the case, then your self-healing algorithms could be really clever, really elaborate, but by definition, they will not cover all of the things that they need to cover because they rely on a human to think of those conditions ahead of time. And we've already admitted that that can't happen.
Right.
So chaos engineering, in contrast, helps the humans get the experience that they need to adapt better. And the output of that might lead to better might lead to better automation. It might lead to self-healing algorithms or failure control algorithms that make the system more robust. But ultimately, it's informing the humans of things about the system that they didn't previously know, and that's what allows them to implicitly change their behavior to make the system more reliable.
That's great, and that's really that paints the picture there. I think trying to get, and I'm still somewhat new to some of this, but the impression what you're saying is that there's effectively robustness and resilience are at two different levels, and that resilience is a higher level of decision making that comes into play once the automated systems have failed, which they will do.
Yeah, I think that's a valid way to look at it. I view them as just different properties. Like your system is robust in different ways up to a different point, and there's always
Hmm.
some boundary where it's not robust past that point, right? The simplest thing we could think of is like you load test the system. Eventually, at some point, it's going to fail. Um, any physical system. Whereas resilience doesn't know if something's going to fail. Like there's no proof to say that, well, we could do this instead. There's always the option. You just can't enumerate all of the options for doing something else instead.
Hmm. Right. Right. It's definitely fits the pattern that we see, and you're talking about that the level of complexity is uh, increasing beyond our ability to manage it, and this is something that we do naturally. We've been doing for decades. Is that this arms race between complexity and the tools to manage it, and complexity always seems to win. The
Well, I don't know if it's winning, but I mean, this is, and not to not to plug, I'll plug you for you, but one of the reasons I'm a fan of LaunchDarkly is because feature flags are, it's an explicit design decision that you can make in order to improve your ability to navigate a complex system, right? If you think about it, like we in software, we pretend like complex systems are the enemy. Right. Whereas in the rest of our life, I mean, software is probably the simplest system that we as humans still deal with. If you think about the complexity of human interactions or even driving a car and mentally modeling what other drivers are doing. I mean, this is why autonomous driving isn't successful yet. They can't mentally model another human and their intentions in the other car. It's not that they can't figure out the physics. That's the easy part. So we as people, even as software engineers, we handle complex systems all the time. That's our baseline of just living. But we don't like to see it in our work for some reason. So really, complex systems are not the enemy. That's what allows us to be successful. But we need things like feature flags to give us the comfort with the complex systems that we're building. We need to know I can make this design decision and then change my mind really quickly if I need to. And so that's why I see a lot of power in what you all are doing.
Yeah, it's and thank you for talking about reversibility in that way. And the thing I really loved there, talking about the reversibility on the different timescales. You've got at the project timescale, which is like agile versus waterfall, and being able to change direction within a single iteration, within a couple of weeks. And then you've got, all the way down to reversibility at much smaller timescales to remediate quickly.
If you hired a consultant to improve your feature velocity, right? Like they would focus at the process level, and that's that's great. You could do I don't know, implement Agile or Scrum or whatever, and implement that. But really, like what we want to do is we want to make those architectural decisions that are going to improve feature velocity. And that's like, it's more comfortable, it's more powerful, it's more measurable. It's like everything about that's nicer, right?
Right. Yeah, exactly. It's like we've got the tools. If we can see the tools right in front of us, the process gains are theoretical. They're much harder to grasp. When we see the tools right in front of us and include them in our daily work, and we can, being able to flip a flag and see something change within milliseconds is that wonderful tactile reassurance.
Yeah.
So we've got already some great questions coming in. We have from Deeparzic, my colleague Dawn, so asking, what tips do you have for junior or new employees on where to start with? Well, this is about actually not chaos engineering, but incident resolution. So I know you get often asked about how to start with chaos engineering, but let's take a step back and say, okay, based on what you've learned about, especially with the myths, what do you think where do you think most value is in establishing incident resolution practices?
Okay, so the place I would start is by studying what the resilience engineering community has to say about incident postmortems or learning reviews, or where I prefer learning review than postmortem. So a great place to start would be John Allspaugh's material on blameless postmortems. And that goes back a ways. I think, he's got a lot of great material now that kind of moves from, just a blameless postmortem is not sufficient. Really we want to acknowledge that it's not just that we're avoiding blame, it's that an incident itself is faultless. There are no root causes in complex systems. So looking for a root cause, or even acknowledging that, this was the problem, but nobody's to blame for it. Like, that's also not a great approach. And so looking at, faultless learning reviews is a much more powerful way to think about incident response management when you think of incidents as teachable moments.
Right.
And then in terms of just time to remediate, there's plenty of models out there. I don't have a personal favorite, but there are plenty of models that come from things outside of software that work better for different organizations. So on the one hand, you have models where there's an incident commander, and and they coordinate, and you develop a group that way. There's research showing that the cost of coordination of an incident response, having an incident coordinator, can sometimes be higher than just having the people who do the work normally, the knowledge workers, have the tools and capability of making the decisions that they need to, being empowered to remediate the incident themselves. So there's a lot of interesting research going on there. But I don't have a particular recommendation on the incident response, the incident remediation. On the incident response management and how you understand that, I think there's a lot of conclusive evidence around how to properly run, or how, or at least there's a lot of evidence on how to poorly run a postmortem or a root cause analysis session, and those are all indicative towards better processes that won't be wasting your time. I think that was a roundabout way of answering that question, but hopefully there's something in there.
No, that's great. That's great. I think definitely, the blameless postmortems, I think we've all, fortunately, that's something that I've seen taken up pretty well. And people like Allsport, really talking about the traditional types of root cause analysis don't really apply here. That there's
and his company, Adaptive Capacity, his company Adaptive Capacity Labs has a bunch of great research on metrics you can use to kind of understand your own plate. Like if people want to read the briefings after a learning review, that's a good indication that you're doing that well.
Yes. Excellent. We have another question, LordTran888, about feature flags, which is to do with what are good ways to manage dependencies when you start to get more than a few. And I suppose this ties into, so this is more technical, and this is obviously something that we at LaunchDarkly have a whole bunch of opinions about. And I think I might actually expand this out. If you have specific opinions on that, I'd be very interested to hear them. But I think it also ties into the bigger question about relationships as a pillar of complexity. In that, more specifically, dependencies, right? And this is something I've always wondered about, is having been at companies that dealt with massive legacy systems and realizing the ludicrous numbers of dependencies, not just, for example, software dependencies, but organizational and event dependencies, all kinds of bizarre things that felt impossible to track. So for these kinds of things, how do you advise that people manage all these kind of dependencies once they start to expand?
Yeah, so I am not an expert in dependency management. I've certainly seen people bitten by the bug of having too many unmanaged feature flags, or at Netflix they call them fast properties. I think there's a bunch of interesting approaches to that, but I'm certainly not an expert in dependency management. I would say that we should expect that as the layers of abstraction increase beneath us, that navigating that as a problem of complexity rather than solving it is probably more useful.
Right.
Or it's probably a better use of our time.
So it's and you're right. So I see what you're saying in terms of in that, though it may add the number of relationships, they're there for a reason.
Yeah, and sometimes the reason might not even be apparent to you, or it might not even be valuable to your particular goals in a pursuit or an organization or a business. For example, we at Verica, we did a lot of research in 2019, and one of the things that we saw across the enterprise market is let's say some frustration with Kubernetes as this additional layer in the deployment process. For many people, that's not a virtue, right? And it runs, just maintaining Kubernetes as a platform, let alone figuring out new ways to integrate with it, is additional work that doesn't advance their particular goals in a smaller context. There's a similarity there to the explosion of dependencies, where if you're focused on the developer experience and dependency management from a language or a library or security point of view, of course you want to limit the number of dependencies. But if you're an engineer who's got different pressures and you're trying to increase the rate at which you're delivering features, then you've got the opposite pressure. Like, oh, let me bring in as many dependencies as possible because I want to take other people's work and make use of that. Depending on where you are, you might not. You might have a different perspective on the proliferation of dependencies at all. I'm in the camp of inbox zero is a nice idea, but at some point you reach a rate at which important emails are coming in where you just have to let it go. And I know right now that approach for dependency management would make a lot of people scream in frustration, and I understand that, but there's again, I'm not an expert in that field, so I should stop there.
Well, no, I think there's a fascinating guiding philosophy here, which I think applies to so many people who deal well in complex situations, which is go with the flow, right? You aren't going to fight it. It's there for a reason. The best thing you can do is get better at navigating it, get better at diagnosing, right? This is dear to my heart because I give talks about debugging. And what I find is that too many people don't understand how powerful and easy to use their own debugger is, right? And also how valuable it is to build custom tools for your situation. I have rarely been in any situation where a custom tool that was created for a system did not pay for itself within a couple of months, right? So that kind of evolution
so that's a mechanism for you to so that's a mechanism for you to navigate a complex system better as an engineer. You create custom tools. That makes sense.
So a lot of people are going to be, are wondering specifically about the chaos engineering aspect. And I'm sure, I think we talked just before this and people want to go, I want to start blowing stuff up automatically. How can I start blowing stuff up automatically? Or more specifically, how can I start applying chaos engineering in my organization? And how can I persuade management that to go along with it? And I suppose this depends on how you portray it. But what do you think of? What's the advice you give in these situations?
Well, I mean, first of all, I would say I hear there's a really good book out on this that just hit the shelves. Wow,
let me bring that slide up again. There we go.
But the general pattern that we see for companies adopting, and it's a widely adopted practice now, but the general pattern we see is start with a game day. This is there's plenty of ways to do that, but basically what we want to do is we want to bring people with expertise in a room together to start discussing the repercussions of or the system behavior outside of the normal happy path operations. So just the discussion alone can often help uncover knowledge gaps about how the system actually behaves. So game day, you get in a room, you go, okay, we're gonna, this piece of infrastructure over here, we're gonna take it down for a few hours, and our assumption is that customers won't be impacted. So the hypothesis for an availability chaos experiment almost always follows the form of under X conditions, customers still have a good time, right? If your hypothesis is under X conditions, they'll have a bad time, then don't run that experiment, right? That's just a terrible experiment, right? If you think you think it's gonna, so some of the impression of chaos engineering, that's bold, or that's too risky. No, it should not be a risky thing, right? Like if you think something's going to break, obviously don't do that. Fix it before you do anything.
Right.
With it. Or another way of saying that is chaos engineering is not about causing chaos engineering, or is not about causing chaos in your system. Yeah. There's an assumption that the chaos is already in the system, and you're trying to surface that so that you can better avoid the pitfalls. So that's a great way to get started. Plan a game day or war room scenario where you kind of plan out, and then dip your toe in the waters that way. It is a best practice or the gold standard to do chaos engineering in production, but certainly we recommend starting in a staging environment if you have one. We see a lot of organizations are moving to not having staging environments, and that's understandable. And feature flags actually makes that a little bit easier. That's fine, but if you do have staging environments or hidden features or different user groups associated with different features, start with the experiments there. There's no reason not to, and hopefully you can learn from the staging environment either about your system in ways that helps you make it more robust, or you build up your skill set for resilience, or you build more confidence in the system, and that you can use that confidence to then move the same tools, the same experiments into production.
Right.
That's the general evolution we see.
That's a great way of putting it, and that ties very well into the whole topic of this regular stream, testing in production. Is that it's less that LaunchDarkly, we have several staging environments. We have development environments. We have a proper staging environment. We did not just ditch it and do everything in production, because, as I say, if you can obviously reduce risk to an experiment, then you should. The reason to test in production is because you already are. You just don't call it that yet. So we're going to have to round this off in a couple of minutes, I'm afraid. But this has been absolutely fascinating. Thank you so much. Before you go, I'm interested to know. Sorry, this is just to end on completely silly. There is a thing that ties into the point you made about the problem with the bad apple theory. That actually the people who are causing those problems are not doing it because they're bad. It's because they're the ones who are being sent in to do the
closest to most problems.
Closest, right? Exactly.
We won't say causing, because that implies that they are the root cause.
Right. Sorry, you're absolutely right. Who the bystanders, the people who happen to be nearby at the time, the chief suspects, maybe. And that it. So I used to work at Linden Lab, where I did most of my learning about complex legacy systems. And if an actual mistake that you made blew up production, then you got to wear the Shrek ears for a day. And similarly, I've seen other organizations do this, but they did a great job of describing. A colleague of mine, Jeff Luan, who is now at LinkedIn, did a great write-up on saying that it's actually a badge of honor, right? It's that you went in to try and do something important and fix something important, and you learned. I know at Etsy, they have the 3-armed jumper. Have you seen, what other good ones have you seen?
At Netflix, they give out badges, or they used to give out badges for having taken down production. I know Google had rituals for this. I understand that, and I get it. I wouldn't say that I entirely support that, because it does still reinforce this notion that one person was a cause, and so
Right.
there's it's basically coincidental. Sabotage is extremely rare, and so if you didn't intend the outcome that was bad, there's no causal relationship in a complex
Right.
system. Um, so that's an adjustment in thinking about how an incident happens. That's different. Like, oh, this person published the line of code that brought down production. Well, what you're actually saying is that the least effort to remediate that is to undo that line of code. But there's alternative narratives to that. It's the fault of the person who wrote the CD tool for not having it automatically staged, or it's the fault of their managers for not communicating better, or it's the fault of their director for not properly budgeting for another environment, or it's the fault of the VP for not allocating and explaining to the board why they need that budget and not choosing a different CD tool, or it's the CTO's fault for not properly explaining the importance and aligning the company around. So now, which of those is more likely to lead to a more reliable solution? Putting the three-arm sweater on the person who put that line of code in production, or changing the behavior of the CTO, right? Changing the behavior of the CTO is much more likely to make that system more reliable. And yet all of the RCA type stuff and the focus on the one person, that's not going to change the reliability of the system at all. Right. Like,
So
the three-arm sweater makes them more comfortable so that they don't carry around the shame. And that's important. But it still locks you into that mentality of like, they're the ones who did it, not the CTO.
So that's interesting, because this points out something that there is a big difference between root cause analysis and, the way I would have got to the CEO through that is the whole 5 whys process, saying, why did that happen? Why did that happen? Why did that happen? Etc.
The problem with 5 whys, Richard Cook likes to say, I've got a 6-year-old who's great at asking why. We could just put them in charge of incident remediation, right? So the 5 whys is entirely arbitrary, and the problem with that is, depending on who facilitates it, they're going to create a narrative that suits their purpose. So if I'm the director in that example, I'm going to drive the 5 whys into, and it's not I'm malicious or doing it on purpose, but I'm going to drive it into, down there among my reports or skip levels, there was a miscommunication. Whereas if you were truly doing it from the bottom up, the 5 whys might lead up to the C level, right? So like the 5 whys as a practice doesn't actually provide better guidance in how you run an investigation. So I'd prefer we don't use that as a crutch. But I understand that in some organizations, in the hands of a well-intentioned and well-informed facilitator, it can make the investigation more palatable to the organization.
So yeah, it's all about perspective. It sounds like, in that, or rather, where you're looking from, and then how. I can see the dichotomy there, or the paradox there, in that if you're looking from the bottom up, you get what may be a more accurate view, but that also means that you have less power to act on it.
It's a different narrative, right? Like, who's to say if one's more accurate or than the other? But you would, in a situation that's hierarchical, it's pretty, well, let's at least say it's intuitive that you're going to change the holistic system much more efficiently if you affect the people at the top of the hierarchy, not the people at the bottom of the hierarchy.
Right.
and really, when we're talking about
makes
safety
sense.
or reliability, we want to look at the holistic system, not the people at the sharp end.
Yeah, because the whole point of the buck stops here sign, as it were, it's right, the power, if you're getting paid the big bucks to be at the top, that's where the power actually is to fix things. So we would hope. We would hope, exactly. This has been absolutely fascinating. We have to stop there. I could easily talk for another hour or two.
This was a lot of fun.
Thank you so much for joining us today.
Thank you for having me on.
Absolute pleasure. Please do come back soon. I am going to be devouring your book. So we're going to be back next week. For those of you watching, thank you so much for joining us. We didn't get to all the questions, I'm afraid. There's a good one about knowledge workers and decision making that may apply, and be good to talk about that soon. But thank you again for joining us. Your book, Chaos Engineering, which you wrote with, so I'll bring the slide back
Nora
up.
Jones.
It's Nora Jones. If you're watching, you can get that for free. That's it from us. Yeah. We'll be back next week. Thank you for the giveaway. And for Casey, CEO of Verica.io, Casey Rosenthal, thank you so much. This has been completely fascinating. The video will be online. Well, it's going to be on Twitch shortly, and then there'll be a proper blog post in a couple of weeks. And we'll be back next week for Test in Production again. Thank you so much. Thank you, Casey. Talk to you soon.
Thank you so much.
Bye-bye.
Talk to you soon.